Hello everyone, my name is Nikun Sundagar and I am from India. Completed MTech in Civil Engineering and specialization in Structural Engineering. So today is our topic about the analysis and design of G plus 5 residential buildings against seismic and earthquake load with manually load combination. So today I want to discuss how to apply different load in a building using Staad. Before the preparation of model, I will show some data. This is the analysis and design of residential G plus 5 building with manual load combination. This is given data. This is the beam size, column size, slab thickness, floor height, and the end support are fixed. This is the exterior wall thickness 0.4 meter, partition wall, and this is the plaster thickness. This is the effective height of the floor. So in which this is 3 meter is the overall floor height, and this is the 0.6. This is the beam depth, and the step thickness is 200 mm. So I deduct this. So 2.6 meter. This is the wall height. And the second thing is the load calculation. We will calculate the dead load, live load as well as seismic load. So first step is a dead load. This is a slab self weight 0.2. That means the total slab thickness into density. You will get the 5 kg per meter square. Then second thing, before the exterior wall, we will calculate the plaster weight. This is the thickness of plaster 0.02 multiply 2.6. This is the effective height of the wall. Then this is a 1 meter length, and the density of the plaster is 18, and this is for both sides. So we get 2 kg per meter. Then the second thing is exterior wall dead load. This is the wall thickness. We will use always in the meter. This is the effective height 2.6 meter. This is the density of wall, and the 2 is the plaster weight. The same way partition wall, and for the parapet wall we will consider the height 1.5 meter, and in the same way we will add 2 for the plaster. Then next, seismic load calculation using 1883-2005. There are three methods: equivalent static method, lumped mass model method, and then third is a response spectrum method. Today I will analyze equivalent static method. Then next video I will analyze response spectrum methods. In the example, we consider equivalent static method. Then what is the procedure? We have to calculate the VB. This is a basic design seismic base shear is equal to AH into W. AH means average response acceleration coefficient, and W is the seismic weight of the building. This is the AH equation. So we will get the answer, and this is the TA, time acceleration. This is a 0.09 H upon root D. Our dimension of the length and width is 50 meter. So we get the TA is 0.348. It is used for the seismic definition. Steps: first of all, prepare model, then generate beam and column property. So new project, space, this is the I save, then meter kilonewton, add beam, open structure wizard, frame model, bay frame. This is so now bay frame length will be 15, height will be 18, and again width will be 15. 8 apply, close, yes, okay. Then go to general properties. You have to define rectangular 0.6 cross 0.45. This is for the beam dimension, and 0.5 cross 0.5 for the column dimension. So for the beam, application of the beam 0. Select the beam criteria, select beam parallel to x direction, select beam parallel to z direction, assign to selected beam, assign yes. Then select column dimension, select beam parallel to y direction, assign to u. Support, create support, fix support, select support, nodal cursor, front view, select isometric view and check all the foundation point node will be selected. Assign to selected node, assign yes. Next step, load definition, seismic definition, edit required data, load and definition, seismic definition, add, select IS code, IS Indian standard, the zone value 0.24, response reduction factor 5, improvement factor 1, broken soul type 2, 1, 0.05, then period in x direction we will calculate at 0.348, 0.348, 0.348, 8, sulfate add, then next floor weight to all the floor weight, that means this is always in positive direction. This is the self weight of the slab 5 from 3 meter to 18 meter. This is 18 meter add. Then next floor weight 2 from 3 to 15. Don't add to the roof load. Then add, then add member weight in unit. This is the member weight, means this is the wall load 22.8, 14 and 9. 22.8, then 14, then 9. So here we add member weight, then seismic definition is completed. So okay, this is 9. Now next load case detail, add load, then select seismic, q, x, eq, z, dead load, then roof load, roof LL. The next load case detail, we can done this. The next seismic load EQX, seismic load factor and direction. We have to apply direction with factor 1. So select EQX, add seismic load direction X, apply with 1. Then close EQY, add seismic load direction Z, and close. Dead load, add sulfate of the member. This is the dead load, sulfate. This is the negative one. Then the floor load. The floor load only assign, no need to apply. So the floor load value we right now we use 0 in the all the floor. That means 3 to 18. Add. Then next is member load. Then member load, we have to write negative. This is the value negative 22.8. Add negative 14 and negative 9. Next assign the load. So this is the outer periphery wall. Select beam parallel to X, select beam parallel to Z, alter VV, then select all the beam excluding roof, alter VV, top view, then select unit gravity Y, then select all the periphery beam, then isometric view, check all the floor will be selected, then assign to beam, assign yes, then select again top view, -14, this is the internal wall, select all the internal wall excluding roof, isometric view, check all the walls will be selected, then assign to selected beam, assign OK, then again isometric top, this is the display wall structure front view, select this last floor roof floor, alter VV, then again top view, then select u -9 kilonewton roof load, then select all the periphery beam, then assign to selected beam, assign yes. So now we have to note that using assign to edit list, copy above member, load to seismic member weight means we have to apply these three load we not applied. So now what should we do? Select this assign to edit list, copy all the members and paste over here. Same things for so the model got 0 error and 2 warning, then done. Then next step is post processing. This is the post processing mode, apply OK, then we have to check the bending moment curve, so we get the value from each and every graph. You can check it, the moment value, then the reaction, this is all the bottom point reaction, and the value will be 310.626 kilonewton to this foundation. Next step, load combination for the seismic load analysis. So here our modeling, then general load combination. Here is the most important thing will be started. This is the very important. Here we apply each and every manual load combination, add, then load define combination. This is a loading combination. 1.5 dead load live load, 1.2 dead load plus live load plus earthquake load. This is a plus minus, and 1.5 dead load plus or minus earthquake load, and again here 0.9 dead load plus or minus 1.5 earthquake load. So let's start. This is 1.5 dead load plus live load. This is the factor 1.5 dead load live load, then add. Then next 1.2 dead load live load plus EQ. This is 1.2 dead load plus live load plus EQX. You have to write the factor 1.2. This is EQX dead load live load. Add. So the same way we have to apply each and every load combination. કેમ થયું આ ભૂલ? 1.5 dead load. So here this is the last load 1.5 dead load minus EQX. All the load combination added here. Then the next close. So all the load combination added. Now general load definition. Define each combination. So we have to done. Then we have to done analyze. This is done. Then analyze, run analyze, save. Again we got 0 error, 2 warning. Then done. We have to start the design. We have to start design, select here, then concrete. Then we have to check the IS code. Then we have to define parameters. Clear that it is a cover 0.025 for beam and 0.04 for column. Then we have to add FC 25,000. Then F5 main 415300. F5 second also 415300. We have to maximum diameter of the bar 25 mm. Maximum second is 12 mm. Then the ratio, this is the longitudinal column ratio. Then close, we have to apply. This is clear. This is for the all beam. Select beam parallel to x direction. Select beam parallel to z direction. Assign to select beam, assign. Then clear. Select beam parallel to select beam parallel to y direction. Assign OK. FC assign to view, assign. F5 main assign to view, assign. F5 second assign to view, assign. F5 main assign to view, F5 second assign to view. The ratio is apply only for the column. So here we already apply for the column. So we'll take copy from the part and paste over here, assign. Okay. Next step is we have to design beam, column and takeoff. So you have to go for command design beam, design column and takeoff. Design beam, we already provide the all the beams, so we copy, edit list and paste in the beam section. Then next 0.04 for column, all copy, design column, paste. We have to take concrete text, so it will give the reinforcement required and concrete design. So now analyze the building. Again it will 0 error. Now we select any beam. Here it's a new pop-up will be generated concrete design. This is the reinforcement required and this is the shear and bending diagram. This is the dead load. This is due to the dead load. Concrete design, you can see here the diameters of the bar. This is a shear, then this is close, this is for column. You can see number of bar size 12, bar number is 20, numbers of bar will be required. So close, then we can see our design will be completed, and the next all the footing design will be done in the next video. So stay with me, stay at home, and like my video, subscribe the channel and share with your friends. Thank you my dear friends. And last thing, this is a PDF file, the steps including the and the few things regarding steps I will add it into the PDF format, so you can download it if you want. Thank you.